Hello to everybody, my name is Oleksii Vodka, I am from Kharkiv Polytechnic University, and today I am going to speak a computer modeling of microstructures with probabilistic cellular automata method using different nucleation rate function. Today in engineering practice there are several materials that are commonly used. In this slide you can see the brass, aluminium, copper, carbon steel, stainless steel, cast iron and their microstructures. But how to obtain them a microstructure? There is several ways to do this, but the well-known is a direct observation using light, microscopy, X-ray, electrons, etc. The sample of microstructure obtained by this method is shown on this slide. Also, there is a way to obtain microstructure using artificial generation. For this, using Voronoi tessellation cellular automata method. The example of Voronoi tessellation from Wikipedia shown on this slide. This assumes that there is a nucleation centers which are marked with the black, and there are grains that grows from grains outside. Another way to produce the artificial microstructure generation is a cellular automata method. This method assumes that the four rules is defined. The first one is a cell space. These cells, which are shown on the right of the slide, the rules, the neighbors, and initial condition. The rule assumes that solidification process is irreversible. If one point is solidified, all neighbors become solid in next step. And neighbors shows how we count the neighbors. There is a well-known phone neighbor, move, left neighbor, and right neighbors. And initial conditions illustrate that cells that are solid in the first step. So in this work is to propose to study the development modification of the method of cellular automata for the simulation of microstructures, develop software that allows to simulate the microstructures of matter according to randomly assigned center of grains, test the work of the software, determine the statistical characteristic of the size, shape and orientation of the grains, compare the results with real microstructures. The next slide illustrates the test situation which use move for neighbor and left and right neighbors. After that, we introduce the probabilistic cell neighbors. That assumes we got ellipse which were projected to a cell space, and after that the area of projected ellipse is calculated. This allows to calculate the probability of these cells and introduce this probability of nucleation in this direction. After that, this case for test cases implemented the probabilistic circle and probabilistic ellipse. The results shown on the slide. After that, there is several microstructures that are generated by well-known neighbors, Moore von Neumann, left, right, probabilistic with circle and probabilistic with ellipse. After that, we introduce the nucleation rates. This rate shows how fast the nucleation the nuclei say is occurring during the nucleation process. Supposed to use cubic, linear, exponential, cumulative density function, and reverse exponential function as nucleation rate function. Using this function, plot in the graph on the next slide. The graph of the left of the slide shows that the function has the same number of grain after 100 iteration of cellular automata method, but they raise it different in nucleation rate. After that, we implement this nucleation rate in our microstructure modeling and obtain the following simulation. You can see a cumulative density function, constant, exponential, and linear nucleation rates. After these models, there is arise a question about equivalence about obtained microstructure to the real ones. For comparison, we use the microstructure of pure iron and special copper alloy, which shown on the right of this picture. To obtain qualitative characteristics, we use three characteristics: the normal form factor, normal error, and scale factor. We calculate these parameters for each grain and build histograms and approximate this kernel density estimation method and for compare the results. The results shown that for characteristics that have look like to the real one microstructure, but there are several differences for CS parameters. The real microstructures left tail is have a higher weight compared to the synthetic microstructures, but very difficult to understand which parameters are best fitted the real microstructures, so that further investigation is required. The conclusions is shown on this slide. Please feel free to write me your questions and visit our website. Thank you for your attention. See you.